Let's go ahead and let's actually start looking at stoichiometry, and let's go ahead and start talking about Mr. Mole here. Section number 2 is going to really be, as I said, with stoichiometry. It's the arithmetic of equations. Some of the objectives specifically that we're going to look at today, we are going to explain how balanced equations apply to both chemistry and everyday life, and we're going to relate how mol-to-mol ratios can now be used to convert from one substance to another, whether we're talking on the molar level, whether we're talking on the gram level. Let's make some cookies. When you bake cookies, a recipe is usually used, telling you the exact amount of each ingredient. If you need more, you can go ahead and double the recipe. If you need more, you can even triple it. If you don't have enough ingredients, then of course you can go ahead and cut the recipe in half and things like that. Thus, a recipe is a lot like a balanced chemical equation. Stoichiometry, well, really, again, just kind of introing for you, Greek for measuring elements. Again, pronounced stoichiometry. But again, it's really defined as the calculations of the quantities in chemical reactions based on a chemical equation, based on a balanced chemical equation. There's going to be 6 different types of stoichiometry calculations that we will be looking at really over the next 3 chapters. Right now we're going to really be talking mostly about solids, but eventually we'll get into gases and specifically how they end up being measured. Again, a little bit of review. Remember, how did we construct mol-to-mol ratios from balanced chemical equations? And again, if you kind of remember that, we said we set each and everything equal to one another using those ratios from that balanced chemical equation. What we're now going to do is we're going to take these ratios and we're going to actually apply them to our first type of stoichiometry, and it's a mol-to-mol stoichiometry calculation. Mol-to-mol conversions. If I look at this equation here, 2Al2O3 decomposes into 4Al plus 3O2. Each time we decompose 2 moles of Al2O3, we're going to produce 3 moles of O2. 2 of these will produce 3 of those. So the first mole ratio that we can have is 2 moles of Al2O3 over 3 moles of O2. Or we can have this, 3 moles of O2 over 2 moles of Al2O3. Again, you might be saying, well, which one do I use? Again, that's where our railroad tracks are going to come in. These are the 2 possible, like I said, mole ratios for you to use in the solution of this problem. Question says, how many moles of O2 are produced when 3.34 moles of Al2O3 decompose? Again, notice the key words here, moles to moles. And as it says up here, this is a mol-to-mol ratio. So we're going to go ahead and start off with our given 3.34 moles of Al2O3. Our conversion factor is this. Again, it's a little bit different. If you go ahead and think back to, I told you set up the railroad tracks, we would go ahead and do this. Okay, and again, moles of Al2O3 are on top, so I would literally want to put the Al2O3 there. I would want to put the moles of O2 there. And again, these numbers, the 3 and the 2, those are just coming from our balanced chemical equation. There's the 3 moles of O2. There's the 2 moles of Al2O3. Since this problem didn't say anything about Al, we don't have to worry about it. We aren't going to use that in our problem. So again, going back, when we go ahead and solve, literally what we are going to do is we're going to take 3.34 multiplied by 3, divided by 2, and you get the answer 5.01 moles of O2. If you know the amount of any chemical in a chemical reaction, you can find the amount of all of the other chemicals, whether it be elements or compounds or even energy in the problem. What I want you doing is I want you doing this one. Okay, come up with an answer. What I'll actually be doing is I'll put this on your Google form and you will give me the correct answer for this problem. Our next one, we're going to go ahead and look at mol-to-mass. Okay, looking at mol-to-mass, it says just like mol-to-mol, we can calculate an actual mass of a reactant needed or product produced in a chemical reaction. It's just going to take a little bit longer of a railroad track. Steps for calculating mol-to-mass. First thing, correctly balance the chemical equation. You're going to find that first step for every stoichiometry. Balance the chemical equation. Step 2, you're going to use that mol-to-mol ratio, just like what we got done doing in our last set of problems. And number 3, you're going to convert from moles to mass using that molar mass of the substance. Question says, if 2.47 moles of C2H2 are burned, how many grams of CO2 are formed? Notice hydrocarbon. Okay, I'm going to have you going back and I'm going to have you writing correct chemical equations, having you remember the different types of reaction. Anytime something burns, it needs O2. And remember, the products in combustion of a hydrocarbon, carbon dioxide and water. But the key part here is, notice it says moles to grams. Grams is a mass. Balancing my chemical equation, I get this. So I'm going to go ahead and start off 2.47 moles of C2H2. Setting up my railroad tracks. Notice, I am dealing with C2H2 and I'm dealing with CO2. So these are the only coefficients right here that I have to worry about. So I'm putting the coefficient, again, C2H2 has to cancel out. So the 2 is going to go on the bottom. I'm going to carbon dioxide, so that one's going to have to go on top, so the 4 are there. But the last step now is I have to go to grams. Okay, so I have to add up what carbon dioxide is. 1 mole of carbon dioxide, add it up, I get 44 grams. So adding it up from the periodic table, 2 times 16 plus the 12, that gives me my 44 grams. Getting my moles to cancel out, I'm going to be left with an answer of grams of CO2. I'm literally going to take 2.47 multiplied by 4, multiplied by 44. We'll divide that by 2, and we'll get the answer of 217.36 grams of CO2. That's your final answer. Again, here was the mol-to-mol step, but I had to go one step further when I was going to grams. I want you to do this one. Okay, and again, this will be on your Google form, looking for an answer on this one. This one, what we'll actually do is we'll do this one in class. Okay, what I want you doing is, I guess, balancing this chemical reaction right here. And balancing this chemical reaction, what we'll do is we'll finish this one up completely in class. But come to class tomorrow with this one balanced for me.